Okay, so the next one, 3 to the 0 times 3 to the 4th. When you're multiplying powers with the same base, you add the exponents. Well, that's still just 3 to the 4th, right? Or I guess you could say 3 times 3 times 3 times 3 times no 3's, still 3 to the 4th. Write it like this maybe. And then we could say 3 to the 4th power. Or this one, 8 squared, 8 times 8 times 8 to the 0. You add the exponents together, and that still leaves you with 8 squared. And that's exactly what you'd expect to happen if something to the 0 power is 1, right? If any number except 0 to the 0 power is 1, then if I say 8 squared times 1, I'd still have 8 squared. Or if I said 3 to the 4th times 1, I'd still have 3 to the 4th. Okay. Negative exponents. Well, we're going to kind of introduce them right here. In this next problem, 5 to the negative 3rd times 5 to the positive 3rd. Since I'm multiplying these powers, I'll add the exponents together. And of course, negative 3 plus 3 is 0. And so the answer is 1. 6 squared times 6 to the negative 2nd, add the exponents together, is going to leave you a 6 to the 0, which of course again is 1. So on your quiz Monday, there is going to be a section that says simplify each power only using positive exponents. Only using positive exponents. Is 0 a positive number? It is not. So if you simplify something and it turns out to be 5 to the 0 power, for example, then you need to write that as 1. Don't leave it as 5 to the 0 power. Okay, so anything to the 0 power except 0 itself, 0 to the 0 power is just still 0. Anything else you need to simplify to 1. Now we briefly talked about this yesterday. So for any non-zero number, raise that number to the 0 power and it's going to equal 1. Sorry, actually, I guess 0 to the 0 power is not 0, it's undefined. I'm still not sure on why they consider it undefined, because you would think if there's no zeros, then nothing, but I guess it just doesn't exist. So 4 to the 0 power is 1, 5 to the 0 power is 1, a to the 0 power is 1, x to the 0 power is 1. I guess 0 to the 0 would just be undefined. And then as far as negative exponents go, we said that it's the reciprocal of that number. So 4 to the negative 2nd is the same as 1 over 4 to the positive 2nd. So if 4 to the 2nd is 16, 4 to the negative 2nd is 1 over 16. Let's practice using our negative exponents. Who's gotten to the 10.4 homework yet in their big ideas? Okay, so you guys are seeing some negative and 0 exponents. 3 to the negative 4th. Now notice how it says evaluate. Evaluate is a word that means we want the actual answer. Don't leave it as a power. If you see simplify, or if it says write as a power, sure, leave it as a power. But if it says evaluate, that's where we want the numerical answer. And this is where your calculators come in handy, because that's where you're going to use your exponent button. 3 to the negative 4th is the same as 1 over 3 to the positive 4th. And so what is 3 to the 4th? Jimmy? 81. So this will be the 1 over 81. 1/81st. Example B. When you're dividing powers with the same base, what do you do with the exponents? Alex? You subtract. Alex, what's 6 minus 7? Okay, so this is negative 3 to the negative 1st power, which is the same as 1 over negative 3 to the 1st power. What's negative 3 to the 1st power? Not 1. Not -1.
0.
Not 0. Still -3, right? Anything to the first power is itself. And it is still going to be negative because 1 is an odd exponent. Remember why we said if there's an even exponent, that negative will cancel out. If there's parentheses, there are here, but 1 is odd. So the way I would probably write this, the best way of writing this is just -1/3. Okay, -1/3. -3 to the first power is -3. So 1 over -3. Now, if you let if you put the negative down here with the 3, that's still the same thing. Heck, you could even put up here with the 1. As long as it's there, I usually write it off to the middle, but as long as it's there, the fraction is negative. All right, example C. -2 to the -5th. Let's start with the reciprocal first. What's that the same as? -2 to the -5th is the same as what? I've already heard from you, Alex, but I haven't heard from Emerson yet. What's that the same as, Emerson? Oh, I don't want an answer yet. I just want you to give me the reciprocal. What would it be the same? What would be the reciprocal of this? Okay, but it should still be negative. Also, it should be in fraction form. Look back to the last one we did. We had -3 to the 4th, for example, A. We said -3, I'm sorry, I said that wrong. 3 to the -4th was 1 over 3 to the +4th. So with that in mind, -2 to the -5th should be one over not 25. Help not Carson. So the -2's on bottom and to the what power? 5. Yes. Okay. So Emerson, look at, see how that's similar to what we did in example A. We said that the negative exponent actually just takes the reciprocal and makes it 1 over 3 to the 4th. This negative exponent is going to make it 1 over -2 to the 5th. The negative exponent does not make your answer negative. Now, your answer may end up being negative. This one's going to be negative, but it doesn't, the negative exponent itself doesn't make your answer negative. It just flips it. Okay. Now, the reason I know this is going to be negative is because I have a negative base and I have an odd exponent, and 5 negatives makes a negative answer. What is 2 to the 5th? 2 times 2 times 2 times 2 times 2. Jimmy? 32. So then I would evaluate this, of course, simplifying it. If I said simplify it, you'd be done. We've simplified this. But if it says evaluate, you'd say that's going to be 1 over 32. And of course, it's negative because we just said 5 negatives makes a negative. So -1 over 32. Example D, 1 over 5 to the 7th times 1 over 5 to the -4th. Sure, Alex, give it a shot here. Well, we're actually going to do this problem the same way we did these problems here. We have the option to simplify each fraction or multiply across top and then multiply across bottom and then simplify. So we have a couple different ways we could do this one. For example, D, it might be easier just to multiply across the top and bottom. What's 1 times 1? 1. And then on the bottom, when I'm multiplying 5 to the 7th times 5 to the -4th, should I add or subtract those exponents? Carter?
Wouldn't you subtract?
I'm multiplying across. And so there is a fraction. So you could think of it as each one is its own little division problem, but what I'm doing right now is multiplying them. So what do I do when I'm multiplying two powers together with the same base? I add their exponents. Can you tell me what 7 plus -4 is?
That'd be 3.
3. Okay. So that gives us 1/5 to the third. And then because again, we're evaluating, go ahead and take it to the next step and answer it. What is 5 to the third? Julia? That's right. So we'll say this is 1/125. Example E. Again, I could multiply across the top. I could simplify top and bottom, reduce or cancel, however you want to say it. There's a lot of different ways I could do this one. If you did multiply across the top, 4 to the 5th times 4 to the -3rd, you would add those exponents. Jace, what would you get when you add the 5 with the -3? Okay. Oops. So on top, we get 4 to the power of 2. On bottom, it's already 4 squared. So now that I've simplified that top part, we divide. And what do you do with the exponents when you divide powers? Brady? You subtract the exponents. So when I'm multiplying powers, I add the exponents. When I'm dividing powers, I subtract them. Brady, what's 2 minus 2? And what's 4 to the 0 the same as? Just 1. Yep, just 1. Here's another way of thinking about it. The 4 to the -3rd right here, those 3 4s, because it's a negative exponent, are all going to drop, reciprocate. All of them are going to drop to the bottom. If those all drop to the bottom, then you're going to have these still on top. These are dropping to the bottom to combine with the other 2 that are already there. There's 4 squared, and then here's 3 more coming. And everything cancels. And if everything cancels, your answer is 1. Okay, next one here. 1 times 1 is 1. 2 times 2 to the -4th. Chloe, what exponent is actually right there that's just invisible right now? There's a 1 right there. That's 2 to the 1st power. And so, Chloe, if I'm multiplying the 2 bottom powers together, because I'm multiplying these fractions, do I add or subtract the exponents? You add them. You're going to add the 1 with the -4. And what is 1 plus -4, Chloe? That's right. So this would be 1/2 to the 3rd power. Deegan, what's 2 to the 3rd power? So 1/8. That's right. Again, there's another way I could think about it. Because this is a negative exponent, those 4 2s are all going to shift up here because they reciprocate. One of them will cancel out with the one that's down there, leaving you 2 to the 3rd, which is 8. Okay, so the instructions are now going to change. We're going from evaluating and writing our answer as 1/81 to simplifying, which means we're just going to actually stop when we get to the 1/3 to the 4th. Okay, so that's what it means to simplify. In fact, there's your instructions. Write each expression using only positive exponents. All right, example A. -5 to the 0 power. What is that the same as? 1. That's right. If the negative was not in parentheses, it would be -1. But because the negative is in parentheses, the 0 exponent applies to it, making the whole thing just 1. Okay. B, 9y to the -3rd over y to the 5th. There's 2 ways of thinking about it. There's the algebraic way, and there's the visual way. The algebraic way would say that when I'm dividing powers with the same base, I subtract the exponents. What's -3 minus 5? Owen? -8. So this becomes 9y to the -8. But because it says only use positive exponents, I can't leave it as y to the -8. I would then change y to the -8 to 1 over y to the 8. Of course, if there's just a 1, then that 9 is the only thing that remains there on top. The y to the 8th drops to the bottom, and that would be my answer. That'd be the algebraic way of doing it. The visual way of doing it is to think of those 3 y's on top because they're negative exponents. Doesn't make your answer negative. It just tells you they're going to drop to the bottom. And if 3 y's drop to the bottom to combine with the 5 that are already there, this just became 9 over y to the 5 plus 3. And of course, that's the same as y to the 8. So you could visually think about, that's how I actually do these. I'm more of a visual. If I see the negative exponent, I know those are dropping, and I just combine them with the ones that are already there. The 9 stays put. There is no exponent with the 9, so we can assume this is just a 1. So the 9 stays put. It's only the y's that are moving. Example C. There's 2 ways to think about this. The algebraic way or the visual way. The algebraic way would say if you're multiplying powers, add the exponents. What's 0 plus -10? -10. And I can't leave it as -10. I have to reciprocate it. Maddox, what's b to the -10th the same as? There you go. That's right. So that's our answer. Yep. Or there's the visual way, which says that's a 1. So it's not even going to do, just imagine those b's aren't even there. There's none of them, right? There's no b's there. So that's gone. And then the 10, the -10 you see are all going to drop to the bottom, making it 1 over, because something has to be on top. It's the 1 has to be on top. And then b to the 10th power. So a few different strategies you could use as you're working through these problems. You could think algebraically, you're going to add the exponents, or you could think of getting rid of the 0 altogether and dropping the 10 b's down to the bottom to make it 1 over b to the 10th. Example D. Who thinks they can tackle with this one without my help? Xander? What do you think you're getting for this?
Well, I think exponent only goes to x.
Correct.
So
Yeah, correct.
it would be 1 over x second squared, and then the 8 is the 1. Yeah,
Like this? Like that? Okay, and what would that simplify to?
8 over x squared.
Yep, you actually, yep, I would just backtrack just a second and just call this 8 over. Yeah, you're not wrong, because x to the -2nd power is 1 over. X to the +2nd power, it's just that 1 is going to multiply with the 8, just turn into an 8. Yep, so we can just leave it like that. We can avoid that extra step. So 8 stays put. The 8 does not move. Someone needs to shut their phone on vibrate. I've heard it a couple times now. Whose ringtone is that? It's not from back there? Okay, well, if that's what you're doing, then stop. I don't know why you'd be doing that right now. It sounded like it was I know the IXL ringtone.
That's live, yeah, it's definitely live 360. I mean, I'll go check my phone. I don't think it's fine. I think that's outside.
Thank you, Alex. I'm not crazy. I was gonna say, I know it's coming from back there. And then Deegan's trying to tell me it's up here on my desk. Like that's where I'm hearing it. So, okay.
Yeah.
While they're figuring it out, our next example, z to the 6th over 15z to the 9th. There are 2 ways of doing this, algebraically or visually. algebraically, the z to the 6th over the z to the 9th, when you're dividing powers, you subtract the exponents. What is 6 minus 9? Negative 3. So this is z to the negative 3rd over 15, because the 15 is on the bottom. But because it's a negative exponent, those are going to have to reciprocate down to the bottom, making this 1 over, as Xander said, there's going to be something there on top, right? That 1's there this time, z to the 3rd power. And that's our final answer. So algebraically, you know that z is to the negative 3rd, so those z's all go to the bottom. Visually, because I'm more of a visual person, I know that these 6 z's are all going to cancel out with all but 3 of these. That's my answer, right? You could just imagine the 6 on top canceling with 6 on bottom, leaving you 3 on bottom. So 1 over 15 z to the 3rd. That's it's the same answer, just a couple different ways to think about doing it. Okay, we haven't done one of these today. We are raising a power to a power. So multiplying powers, add exponents. Dividing the powers, subtract the exponents. What do you do when you're raising a power to a power? What do you do with those exponents? Christian? Multiply them. Christian, what is c to the negative 5th to the 3rd power? That's right, c to the negative 15th, which of course you can't leave it as negative 15th. So we rewrite that as what then, Christian?
1 over to the.
There you go. Yep, just flip it upside down. Reciprocate it. Example G. Same thing here. Who wants to give this one a try? Who I haven't heard from yet today? Brady, I don't know. Brady, go ahead. I don't know if I've heard from you. That's right. Okay. And then what's that the same as? Good. Because it just says simplify, I'm leaving this the way it is. If it said evaluate, then I'd have to do 10 to the 16th power to figure out what huge number my denominator would be. But since it just says simplify, I'm leaving it like this. Example H, be careful. Negative 5 to the 0 power raised to the negative 3rd power. Maddox, you want to give this one a try?
So you're just going to multiply my negative 3 for the exponents.
Okay.
Get you 0.
Okay.
So we have the exponent for negative 5. So then it's 1.
You're really close. What you just said makes it simplify all the way to negative 5 to the 0 power. But it's not 1. Lizzie? It's negative 1. Now, there is parentheses in this problem, correct? But there's 2 exponents. If you look at the 0 exponent is not being applied to the negative sign. They would have had to use 2 sets of parentheses. So we do multiply 0 and negative 3, and that's where he's getting 0 from. But as soon as the 0 and negative 3 have been multiplied together, that set of parentheses is gone, leaving you with just negative 5 to the 0, which means 5 is being raised to the 0 power. It's 1, but the negative never got seen. It was never seen by those nearsighted exponent of 0. So it stays put as just negative 1. Here's another way of thinking about it. The negative exponent is going to turn this into 1 over negative 5 to the 0 times 3, right? And then so that's going to give you 1 over negative 5 to the 0, which is going to give you 1 over negative 1, which then gives you negative 1. Okay, so a couple different ways, strategies you can think about that one. All right. I think that was our last question. We have what, two more? Okay, 3 more. A gigabyte of computer storage space is 2 to the 30th power bytes. The details of a computer are shown. How many bytes of total storage space does the computer have? The computer has 64 gigabytes of storage space, and each gigabyte is 2 to the 30th power. So 2 to the 30th power times 64, but 64 is actually a power of 2. 64 is 2 to the what power? Maddox?
Wait, is it 8?
It's not 8th
I
power.
was thinking, I thought you meant. Well, no.
Xander, 64 is 2 to the, not 4th power, that's 16. Dawson? To the 6th power. 2, 4, 8, 16, 32, 64. And so if I told you to multiply 2 to the 6th power, which is 64, by 2 to the 30th power, what would you do with those exponents? Jimmy? To get 2 to the, that's right. Yeah, so we're just gonna write it as 2 to the 36th. Next one. The projected population of Tennessee in 2030 is about 5 times 5.9 to the 8th. Predict the average number of people per square mile in 2030. So people per square mile. It's a rate, so I'm going to divide this. People. 5 times 5.9 to the 8th. Per square mile. There are 5.9 to the 6th square miles. Not sure why I didn't just write miles squared there, but whatever. I can cancel the 5.9 to the 8th with the 5.9 to the 6th, leaving me 5.9 to the 2nd power. Yeah, and so these 6 are going to go away, cancel with 6 of those. So now I've just got 5 times 5.9 to the 2nd. Can someone take 5.9 to the 2nd times it by 5? $5.9 to the 2nd times 5. Maddox? 174.05. Okay, so that's a prediction of how many people there's going to be per PPL, people per square mile. Not the population in Tennessee is not going to be 174 people. That's how many people they're predicting per square mile. And let's do our last one here. A drop of water leaks from a faucet every second. How many liters of water leak if the faucet's on for 1 hour? Ooh. So this is how much water leaks in 1 second. Times that by the number of seconds in an hour. How many seconds are there in 1 hour? Alex? 60 to the 2nd power, maybe. Yeah, so there's 60 seconds in a minute, 60 minutes in an hour. 60 times 60 is 3,600. What's 50 to the negative 2nd power the same as? Get that for me, Carter. What is that? Jimmy? What did you say 50 to the 2nd power was? 2,500. Okay, so we'll just call that 2,500.
Mr. Bright,
Yeah,
did you get the controller to Mr. White?
wait,
Mr. Wright,
Mr. Wait, I will today at practice. Yeah.
he said he will.
Okay, what do you get? What's 3,600 divided by
I couldn't hear
2,500?
what she was saying.
This is awkward. Maddox? What is it? 11.45? 1.44 liters. Yeah, so you're timesing one, actually, you're really just dividing, aren't you? Just dividing those two right there, because this is over 1. And so that's gonna mean 1.44 liters per hour of water being wasted. All right, if you have questions over your negative or zero exponents, you can come see. Today's Wednesday, this homework's due Friday. You still got 2 days plus a work day tomorrow. I'll see you guys later.